Okay, we're going to start 7.2. In 3, 2, 1. When I say 1, it should be quiet. 3, 2, 1. Thank you. Okay, put your phones away, get your books out. We are going to learn about sequences. So, what do you remember about sequences from last year? Anybody remember anything? Okay, so if I have a list of numbers in a row, can I predict the next number? Okay, so that's a sequence, right? So what do we remember about them?
Wait, is this a theory thing?
That would be Pascal's triangle. Okay, there can be a formula to find the next number. So there's two types of sequences. You're either adding to get to the next number or multiplying to get to the next number, right? Okay, so we're going to use the ones mostly where you multiply. It's called a geometric sequence, okay? So first we need some definitions. So a factorial definition is this little exclamation point guy, okay? So n factorial means I just keep taking one down. So the thing about the sequences that you're learning is that the notation can be harder than what it really means, okay? So this says I start with the number n, and then I write it, and then the next thing I do is I subtract 1 from n, then I subtract 2 from n. So what if my number was 6? So if I were doing 6 factorial, the first thing I would write would be a 6, and then 6 minus 1 is 5, 6 minus 2, 3, 2, 1, okay? So all it means is you start with the number and you subtract 1 and you go down. You multiply those all together. There is a factorial key in your calculator, okay? There's a couple ways to get to it. So you can push the math button, go over to probability, and then it's number 4, okay? So you push math, go over to probability, and then it's number 4, okay? I believe it's also in the catalog, so if you did the second 0 and went to your catalog and went to the very bottom of your screen, they're after the alphabet, okay, with your factorials would show up. Okay, but this one, we're gonna simplify a factorial divided by another factorial by writing it out in terms of n, okay? So if I have n plus 2 factorial, I'm going to start with an n plus 2, okay? And then what is my next term going to be? N plus 1, perfect, because remember we subtract 1, and then the next one, and then the next one, and then the next one. Okay. So what I want you to notice is that from this n, okay, just like this up here, n minus 1, n minus 2, n minus 3, I start with n, and then I have n minus 1, n minus 2, and it will just go forever. That's going to be same with this factorial on the bottom. So n factorial is going to be n times n minus 1 times n minus 2, right? So notice that this is an n factorial, and this is an n factorial. So once I get them where they're the same, then I can cross them off. Okay, so this will reduce to n plus 2 times n plus 1. Okay, if I wrote it a different way, I could say this is n plus 2, this is n plus 1, thank you, and then this is n factorial, right? If I wrote this, and then instead of n and keep going, I could just call this n factorial, right? Because I'm just going to keep going. And then the denominator is n factorial, so then those cross off. Okay? So that's how we got that. Okay? This is what it would be the same as with numbers. So if I had n plus 2 factorial, this is like 8 factorial divided by 6 factorial, right? With numbers. So 8 factorial is 8 times 7, and then I could write times 6 factorial. And then the bottom is 6 factorial, and those will cross off. Okay? So that's what we're doing with numbers. It gets a little more confusing sometimes when you throw some variables in there. Okay? All right, so let's start with some notation. So this says a sequence is an ordered list of numbers. An ordered list of numbers means there is some sort of formula that I can use to come up with the next number, right? So arithmetic sequence means I'm adding the same number over and over and over again. Geometric means I'm multiplying the same number over and over and over again. And then if I'm doing something different than that, then it's neither of those, but it still has an order. It's still ordered, okay? Because it's called a sequence. It has to have some pattern, okay? So your job is usually to figure out what the pattern is, okay? All right, so this says write out the first 5 terms of the sequence, AN. So I'm going to put some numbers in for these n's for a minute so you can see how they work, okay? So the whole sequence is called AN, okay? So AN is going to be A1 if I put a 1 in place of n. I'm putting a 1 in place of n. What is the top going to be? 1. And what's the bottom going to be? 1 plus 1. I'm going to write it like this so that you can see where the numbers are coming from, okay? So that would be the first term is 1 over 2. Okay, and then if I'm finding A2, which means the second term, okay, because there's a 2 there. Now I'm going to plug in a 2 on top and then a 2 plus 1, right? And that would be 2/3. And I can do that all the way until A5, which is what it asks for. Okay, we just keep plugging in. And 1, 2, 3, 4, okay. And then our last one, A5, is 5 over 5 plus 1, which is 5 over 6. Okay, so at this point, when you look at these numbers, could you write the next number without using the formula? Okay, what would it be? 6 over 7, and then the one after that? 7 over 8. So you notice that the top number is 1 smaller than the bottom number, right? Good. So you're figuring out convergence or divergence, okay? So if it asks for the first 5 terms, then I'm going to write 1/2, comma, 2/3, comma, and you're just going to write the 5 terms in a row. Okay, so that gives us the first 5 terms. All right, so what that is, you guys, when it says AN, is that I can find any term. If I wanted the 100th term, what would the 100th term be? Okay, this one is a little bit easier to know what the 99th term would be, or the 100th term without knowing the 99th. So this is going to be the difference if it's recursively defined. Okay, so recursively means you need to know the previous term to find the next one. Okay, so the k plus 1 right here, that means the next term, okay? And then where it's just k here, that means, so whatever number I had before, I'm going to multiply that number by 3, and then I'm going to add 4 to get the next number, okay? So recursive means I know the previous term. That's what a recursive formula means. A general formula, or just the standard form, that will work for any term, right? So I'm plugging in whatever I'm solving for instead of doing something to the previous term. So Recursively means that you're looking for the previous term and then you're going to do math to that. Okay? So if this tells me that the first term is 5, that means that k is 1. So if I plug into this formula, I would have a and then k plus 1 would be 2. So that means the second term, right? We're finding A2 using A1. Good. So 3 times, and then A1 plus 4 is 3 times 5 plus 4, which gives us 19. Okay? So that's the recursive one. So now this says find the first 5 terms. So I know the first one's 5. I know the second one is 19. What's the next one gonna be? So A3, I'm gonna take 3, I'm gonna multiply that by 19, and then I'm gonna add 4. See how I needed that 19 to find the next term instead of just plugging in 2? You see the difference? Nod your head yes if you do. You okay? All right. So that means A3 is what? 61. And then A4, 3 times 61 plus 4, so A4, 187. So it's getting big pretty fast. 3 times 187 plus 4 is 565. And now we have our 5 terms. So what was the first term? 5, right? So 5, and then the second one was 19, 61, 187, and 565. Page there. So 1, 2, 3, 4, 5. So when I found the second term, I plugged in the first term here instead of plugging in a 2 like we did over here. Okay? So recursive means you're using the previous term. So every one of these that I circle, that's the previous term to go into that formula instead of just the 1 or the 2 or the 3 or the 4 or the 5. Okay? So that's the difference with recursive. All right. So then it says write a recursive definition for the sequence. Write a recursive definition for the sequence. So you have to write down what A1 is. What's A1? A1 is 2. And then if I'm doing AK plus 1, that's A2, right? So how am I going from 2 to negative 6? Negative 3 times AK, right? Good job. So that means whatever the previous term was, I'm going to multiply it by negative 3 to get to the next term. Okay? All right. Now this says, write an expression for the nth term of the sequence. So the nth term is the standard formula or the basic formula. So what would I plug in, or what? I need a formula so that when I plug in a 1 for the first term, I get 2. And when I plug in a 2 to get the second term, I get negative 6. Uh-huh. So to get from 6 to 18, what are you multiplying by? And to get from 18 to negative 54, what are we multiplying by? So we're multiplying by the same number. What kind of sequence is that? It's a geometric sequence, right? And so when we do a geometric sequence, we have R, which is called the common ratio. Okay, so the common ratio is -3. We figured that out. Okay, so if I take -3 and I raise it to a power over and over and over again, I'm going to get the 6, right? And we're going to figure out, we're multiplying it how many times. So now, to get the nth term, I know I have to start with a 2, right? I start with a 2, and then I multiply that by -3. And the first time I did it, I multiplied the -3 to the 1 power, right? And the second time I did it, what did I multiply by? 3 squared is 9, right? And then 9 times 2 is 18. So 3 to the 1, 3 to the 2, 3 to the 3, right? So this gives you 3, this gives you 9, this gives you 27, and then every time we're multiplying by the 2 that we started with. Okay, so how am I going to get 2 for my first term when I put n in here? What does my power need to be? Power needs to be 0. So my power needs to be 0. So that means when I plug a 1 in and I get a 0, what's my formula? There you go. N minus 1. Okay, so when you do the n minus 1, if I plug a 1 in, I get a 0. That gives me my first term. If I plug a 2 in, what do I get? A 1, and that gives you your second term. What about a 3? Now, you need to check your negative, okay? So the first term is a positive, which means my 2 has to multiply by a positive 1, right? Or a positive, 1 because of the 0 power. When I plug in a 2 for n, that's the second term, I need this -3 to stay negative, right? So I need this power to be an odd power, okay? Now, if they were switched around where this started out negative, positive, and negative, then what you do, and I'm just going to put it right here so you can see it, is you do a -1 to the n minus 1 power as well, and then that puts a -1 there for you, okay? Or to the n power, depending on what you need, okay? Either n or n minus 1. So that's how you change the sign around. You multiply by that -1. So right here, we have discovered the geometric formula, okay? Geometric formula for any term. You will use this a ton in Calc 2, okay? So it's the nth term of the geometric formula is the first term times r to the n minus 1 power. So if you figure out that you're multiplying by something over and over and over again, that's geometric, okay, if you can find a common ratio. The way that you can find a common ratio is divide. I shouldn't write a 2 and a 1. I should write AK plus 1 divided by AK if you're being with letters, okay? So you basically divide the next term by the previous term, and that will give you your R. So if I took the -6 and I divided by 2, I would get 3. That would give me R, or -3. 18 divided by -6 gives you -3. -54 divided by 18 gives you -3. Does that make sense? So that's how you find R, is you divide. Okay? All right, so let's see what we're going to do with this. I don't think we do much with it yet. We're just going to talk about, now this you have to be really careful, because today we're learning about the converging or diverging of a sequence, okay? So sequence is just a list of numbers. It's really important you understand this. A sequence is a list of numbers. A series, which we start learning tomorrow, is when you add the numbers together. It's a sum of the numbers. Okay? So when we talk about convergence or divergence of a sequence or convergence or divergence of a series, it's two totally different things, and you have to look at the wording really carefully on every problem. Does it say sequence or does it say series? Okay? So here we're just talking about sequences for now. So if AN is a sequence, then the limit, as I keep continuing to plug in n, so I plug in a 1, I plug in a 2, I plug in a 3, I plug in a 4, the limit of that sequence is equal to L. Okay? So what that means is, basically, is we're looking at a horizontal asymptote maybe, right, as we go to infinity. Okay? So if I write this one, this says find the limit of the sequence. So the limit as n approaches infinity of the sequence Bn. Okay, so you could either write Bn here or you can actually write the sequence. It doesn't matter what you write there. Sometimes we want to save, we don't want to write as much. Okay, that's going to be equal to, I'll let you look at it for a minute. What do you think that's going to be equal to? So what would that horizontal asymptote be? Are the powers the same? What do we do when they're the same? So what do we get? The powers are the same. These are both have a 1 power. So then I go to my coefficient. So this coefficient of 1 and this coefficient is a -2. So this is going to have a limit of -1/2. What that means is the terms are going to get smaller and smaller and smaller. Okay? So if I look at the first term, the next term is going to be smaller than that. And the next term is going to be even smaller than that. And it's going to go all the way to -1/2, but it's never going to hit -1/2. And it'll never get smaller than -1/2. Okay? But this is looking at individual terms, one at a time. Is the term getting smaller? When we do series, we're talking about the sum. If I keep adding, does it get smaller and smaller, or do I just add more and more and more and more and get bigger and bigger and bigger? Okay? So right now, we're only talking about the terms in a sequence. Okay, so if this was vice versa, if there was not a limit, if the power of the top was bigger than the bottom, then it would be a diverging sequence. Okay? All right, so let's talk about what I just said. If the limit does not have a limit, then it diverges. Okay? So if you don't have a limit, then it will diverge, which means it's faster on top than the bottom. Fast over slow would diverge. Okay? So if I'm looking at this one on number 7, so sometimes I can't do a horizontal asymptote, I just have to plug some numbers in and see what's happening to the numbers. So if I plug in a 1 for n, I'm going to get 3 plus -1 to the 1 power. So that stays negative, right? That's all I need to know. Is this going to stay negative or positive? So if I put a 1 here, it's going to stay negative. So 3 minus 1 is 2. If I plug a 2 in, then this is going to be -1 squared. -1 squared is positive. So then it would go 3 plus 1 is 4. And then if I plug a 3 in, what's going to happen? It's going to go back to 2. And if I plug a 4 in, so what's happening is it's oscillating, right? I don't know if I'm going to spell that right, but we'll try. Oscillating, okay? So if it oscillates like that, where it goes back and forth, back and forth, back and forth, you're never going to hit a limit that that will go to. So you call this, and then I need to show you the notation too. So I always put my set like this. This means the set is the sequence AN, and then I'm going to go, the sequence has a 2, 4, 2, 4, And then it's going to keep going forever. So when it keeps going forever, I do dot, dot, dot. Okay? And then that is going to diverge. So we're looking to see, does it converge to a number in the limit, or does it diverge and keep going off forever and ever and ever? Okay? All right, so this one, now we're going to see if it converges or diverges. So we're going to take the limit as n approaches infinity. Make sure I write this right.
How do we know, like why on the other one did we not do the limit one to now we can do it?
Because on this one, it's just going to go 2, 4, 2, 4, 2, 4. Sometimes you plug in numbers and sometimes you don't. Like you're just going to have to look at the equation to see what you think you do. So on this one, I'm going to say the natural log of n squared. This is the same thing as the 2 down in front, right? Do you remember that? Because the 2, that's the power, comes down in front for logs. So I'm basically doing a natural log over a linear. Which one's faster and which one's slower? This is slow, right? And this is faster. So we write fast, even though it's not super fast. So what's that limit going to be? Slow over fast, what does it go to? 0. And that converges. Okay. So a sequence is monotonic. Yes.
Please, let's pause one.
Yep. Yep. Good. Okay. So a sequence is monotonic. Okay. So if it is non-increasing or non-decreasing, which is a really confusing way of writing, monotonic means it's strictly increasing. So the terms are going to get bigger and bigger and bigger and bigger and bigger, or strictly decreasing. Remember we talked about this before when we were doing inverses. So the largest spot where it has an inverse is where it has the biggest interval of increasing or decreasing, or where it's monotonic. Okay. A sequence is bounded if every term is greater than or equal to some number n, and also every term is less than or equal to some number m. Okay, so what we're trying to say on this one, even though this diverges, right? So we already did this one. So I know that this one goes 2, 4, 2, 4, dot, 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 okay? So the lowest number it's ever going to be is what? 2. And the highest number it's ever going to be is 4. So this is bounded. Okay? It is bounded because there is a low and there's a low and a high. Okay? But it is not monotonic, right? It's going from 2 to 4, 2 to 4, 2 to 4. So not monotonic.
So I need to write not monotonic, even if I write bounded.
Yes, you need to write both. You're answering, is it monotonic and is it bounded?
So it can be bounded and monotonic at the same time.
Ooh, we've got 10 minutes. Okay, so now.
Students and teachers, this part of the interruption, as you are aware, the assembly is open for class changes for second semester. Please remember that all attendance must be taken manually until our unit is closed. And please take the other precautions so that everyone may stay open for the students. Thank you.
All right, so here we've got determine if it's monotonic or bounded. So the only thing I can do is start putting in numbers, right? So what would be my first number? And my next number,
3. A 2.
plugging a 2 in, so 4 over,
3,
okay? The next one,
4, 2, 3,
plug a 3 in, what's the top?
6, 6 over 3.
Okay, the next one,
5. No, 4.
Oh, this is so confusing. 5.
plugging in a 4. So it might help you if you write at the bottom, n equals 1, n equals 2, n equals 3, n equals 4. Okay, so if I plug a 4 in, I get 8 over 5. Okay, and then 10 over 6. So what's happening to these numbers?
You're getting bigger, slightly bigger. Ever so slightly.
Is 1 bigger than 4/3?
Yeah, no.
No.
Or I should say that the other way. Is 4/3 bigger than 1?
Yeah.
Okay, 6/4 bigger than 4/3?
Yeah.
Okay, so it's getting a little bit bigger every time. So what do we call that? Monotonic. Because it's strictly increasing. And then is it bounded? So does it have a low number
Yeah, 1. Yeah.
and a high number?
No.
Is there a horizontal asymptote?
No.
Wait,
As far as we know.
We don't have to divergence or divergence.
Okay, what's the limit as n approaches infinity of Vn? It's 2, right? So the lowest it's going to be is 1, and the highest it's going to be, right? That's not equal to 2. So that is bounded. Bounded between 1 and 2,
How did you find out that it's bounded at 1?
because that's the first number.
So how did you find out it's bounded?
So that's the lowest, because every number after 1 is bigger than it, so it's never going to go lower than 1.
yeah, how did you find it at 2?
The horizontal asymptote of this equation is 2 over 1, so it's 2.
So do we have to keep the convergence or divergence for the boundary?
Yes, you would need to know if there's a limit. Yep. Okay, all right, I think you have 2 more examples of that same thing. So 11. Let's plug some numbers in. So get used to your notation. So when I write a set, I always do the little bracket. So I'm saying this set, if I start with a 1, goes 1 and then 1/2, a third, a fourth, a fifth, ... And that's the end of my set. It keeps going forever and ever and ever. Okay. So is that strictly increasing or strictly decreasing? Decreasing. So that's monotonic. Okay, and then is it bounded or unbounded? So what's the horizontal asymptote? So the limit as n approaches infinity is 0. And what's the highest it will ever go? So this is bounded between 0 and 1, right?
Where it's bounded from?
No, I'm just showing you. Okay, it doesn't ask for that. If it asked for it, you would have to, and some of them it will probably. So that is bounded between 2 numbers, 0 and 1. Upper bound and lower bound. Okay,
Well, why on the 1 is it less than or equal to? Oh, never mind.
it's an asymptote, so it's never going to touch it. Right? Okay, plug in a 1. 1/2. Plug in a 2. 4 over. Plug in a 3. Okay. So is that strictly increasing or strictly decreasing? It's always going up a little bit, right? So monotonic. And then the lowest is a 1/2. Is there a limit? top is bigger than the bottom, so this diverges, so it's unbounded. The power of the top, yep, is greater than the power of the bottom. Okay. So that means there's no limit, it's unbounded. Okay, I'm gonna stop this, you guys, and then I'll get back on.